就因為有項目 cancel 咗啦，所以依家就進度有少少拖後咗。咁所以咧，我哋今次咧就同學咧就淨係做到第6題就得啦，即係7、8、9咧就如果你做咗咁都唔緊要嘅。咁我哋下一段嘅 assignment 2咧都會出現翻呢3題嘅，即係咁樣嗱。如果你呢次做咗嘅，咁你咪當下一次嘅 assignment 2你咪就將呢次嘅答案係交翻咯嚇。咁我哋呢次就淨係需要交1至6嘅呢6題就得啦。OK， 咁我亦都會update 翻啦，淨係做係啦 ，question 1到 question 6就 OK 啦。但係淨係第6題先可以用Excel 啊。其他因為呢題實在係嗰啲如果手寫嘅話，你有排抄嘅嚇。咁 Excel 就好簡單嘅用嚇。咁就1至5題咧都建議都要手寫嘅，因為呢啲都希望大家手寫嘅方式練一練下，因為大家都過來人啦嚇。咁如果電腦嘅話咧，大家就好容易去互相借鑑啦。淨係需要做 question 1到 question 6就 OK 啦嚇。咁剩低後邊嗰3題咧，我會擺過去 assignment 2嘅嚇。咁就大家如果有啲同學咧就好快就做咗咧，咁唔緊要嘅。咁你亦都total 嚟講，你係都要完成嘅嚇。OK， 咁就係下個禮拜1係個 due day 啦嚇 ，due day 啦。咁我哋學校嘅政策咧就係咧係啦，就根據 student handbook 嘅要求咧，就會遲交1日咧就減10% 嘅。OK， 咁去到第5日都未交嘅，咁就講冇分㗎啦咁樣嘅。OK， 咁所以大家就翻個時間嚇。咁就so we will talk about the tutorial. For the tutorial 3, I have made some update. Okay, previously this question is using the US customary unit. I have made another set of the number that using the SI unit. So we will, and we have not talked about this question yet. And this will be related to one of the assignment question. So we will talk about this one. Now, it is a branching pi system. This is the branching pi system. All right. Now, the upper reservoir, it has elevation of 100 meter, and it flow to the junction. We call it J. Okay, we call this J, and this is reservoir A. We put an A here. And this is pipe 1, and pipe 2, and pipe 3, and the receiving reservoir B and receiving reservoir C. Okay, the junction. So that the flow has been point out that the flow is from the reservoir A to the junction and separate into B to the reservoir B and C. Okay. C's elevation, water reservoir elevation is 0 meter, and B's is 60 meter. So that we can, but sometimes, okay, for the common sense that the elevation A is highest, so that the flow should be flow to the B and C. Now, if A and B are on the same level, the flow will be flow together from A and B and to the C, okay? So that it will be like this manner, right? So for this kinds of question, we need to combine the energy equation and also the continuity equation to solve it, okay? Now, from the energy equation, we need to write the energy equation between the reservoir A and the junction J, okay? Now, following the flow direction, okay? For example, the energy equation from the A to the junction J. Now, we see that we can consider that there is kinds of the manometer here, okay? So this hand is the Pj over gamma, okay? This hand is Pj over gamma. And supposedly there is not considering the velocity because we will consider that and if this elevation is 0, we call this is Hj totally. Hj totally, okay? And we can consider that the J point may be on the reservoir surface of this manometer here, okay? So we see that for the figure, the reservoir A to here, okay? It is like the PA over gamma plus elevation of A plus the VA square over 2G, no pump and no turbine, right? Is equal to the HJ, which is the sum of the PJ plus elevation J, okay? Pj over gamma plus elevation J, totally Hj plus the Vj square over 2G plus the head loss. This is head loss is in pipe 1, okay? In the pipe 1, so we say that head loss 1. We don't consider the entrance or component head loss, okay? In this calculation, neglect those calculations, okay? So that we can see that the pressure at here is 0, velocity at the reservoir surface 0. Also the manometer surface velocity is 0. So that the following the flow direction, the ZA subtract the HJ is equal to HL1, okay? Now similarly, from the J to the reservoir B, right? From the J to the reservoir B, following flow direction, all right? It will be Hj subtract ZB is equal to the HL2, or we may say, Hj subtract the ZA is equal to HL2. Then J to the C reservoir is Hj subtract ZC equal to HL3. 3 energy hand equation, okay? Another continuity equation. From the continuity equation, we know that the Q1 is equal to Q2 plus Q3. In the junction here, inflow is from pipe 1, outflow is pipe 2 and pipe 3. So continuity equation tells us that the inflow is supposed to be the same as outflow here, right? So here has four equations, okay? Now the task is that how to correlate this information. The ZA, this is B, sorry about this, B, okay? Elevation A, B, C are given. And the head loss is not given, and we need to determine the discharges are not given. XJ are unknown, okay? So we need to correlate them. For the head loss, okay, we use, because the question asking us to determine the flow rate in each pipe, okay? This is our task. So that we may directly work out the discharge. So we can use the head loss calculation by KQ square format. Using Darcy Weisberg equation is AFL over pi squared GD5 Q square format, okay? Now, the given information of the pipe is included the length and the diameter, all right? So the frictional factor we need to determine. Now, pay attention to this statement. Fully turbulent flow, okay? Fully turbulent flow. So that these are the informations we need to use for determining the calculation. All right. The material of the pipe is reverted steel pipes. Okay, reverted steel pipes. So the reverted steel pipe, the relative, the equivalent roughness we can find in the notes. Now in the notes that's reverted steel pipe. Now I have provided two figures. One figure tells us that the reverted steel pipe is 5.6 nm. Another one, the later one, gives us only a range, okay? Only a range, so that we take this number, okay? So we take 5.6 nm number. We take this one, okay? So, so the equivalent roughness is 0.0056 meter, in other words, okay? For the pipe 1, that the length is 300 meter, that the diameter is 0.25. L300, that phi 0.25, okay? So it's, so firstly, we need to find the Ks over D1, okay? Is equal to 0.056 over 0.25. The result is 0.0224, right? Then, because it's the fully turbulent flow, okay, you will know what that means. Now in the Moody diagram, if you still remember, if the flow is fully turbulent, that means that we don't need to determine the Reynolds number, okay? We just need to look for the relative roughness to determine the frictional factor. For example, so the pipe 1, the Ks over D is 0.0224 alright? 0.0224. Where's the cursor? Okay, 0.02 is here, right? 0.03. 22 is approximately 1/2 is here, okay? Half is around here, okay? So that this will give us that the approximate number, okay? 0.006, 0.005, 0.05. So about here is I have actually used the because the fully turbulent, I have used this Plato-Common equation to find it. Okay, the result of the frictional factor also matched with this one. It is found to be about 0.51 here. Okay, the frictional factor is 0.051 for this pipe 1. Okay. For the pipe 2, length is 100, and the diameter here is 0.2. Okay, 200 mm. So the Ks over D2, it is equal to the result of similar calculation, okay, save the time, it is 0.028. The frictional factor for the pipe 2 is found to be 0.056. Pipe 3 is length of 400 meter, phi of 0.1. The Ks over D3 is equal to 0.056. The frictional factor is a bit large, 0.076. Okay, about this. And then we will calculate the head loss coefficient, the K coefficient. K1 is equal to 8 times 8FL. 8 times is 0.051 times the length, 300 meter, over the pi square times 9.81 times D's power 5, 0.25 power 5. Okay, the K1 is calculated to be 1295 approximately. Okay, number. Now, similarly for K2. K2 is also 8F2, length 2, pi squared GD2, okay? At the same time, the K2 is around 1446. K3 is 24780, A1, okay? So that means the head loss in pipe 1. Head loss in pipe 1 is equal to K1Q1, okay, square. K1Q1 square. That means it is equal to 1295Q1 square. HL2 is equal to 1446Q2 square. HL3 is equal to 247,881 Q3 squared. So this equation, this full equation, this ZA, or we input, okay, we input that the equation ZA is 100 meter, subtract HJ is equal to 1295 Q1 squared, right? The second equation is HJ subtract ZB, which is 60 meter for the second reservoir, okay? B reservoir, okay? Is equal to HL2, which is 1446 Q2 squared. Equation 3, HJ subtract ZC is 0. So that it is 0, okay? We also copy this. Is 247,881 Q3 squared. And so for the Q's, okay, so for the Q's, that the Q1 is equal to, square roots 100 subtract HJ over 1295. Q2 is equal to square roots of HJ subtract 60 over 1446. Q3 is equal to, now subtract 0, okay, so that is HJ over 247,881. And then we put the Q1, Q2, Q3 into this equation, the continuity equation. Then I may need to turn to a new page, okay? If you want to, you can take a picture first. So next we know that it is the continuity equation. Q1 is equal to Q2 plus Q3. So that's, or we say that the Q1 subtract Q2 subtract Q3 is equal to 0. So we have the square roots 100 subtract HJ over the K1 1295. Subtract the square root HJ, subtract 60 over 1446. Subtract the HJ over 247,881 is equal to 0. Now the task is to find out the HJ. Okay, so there is no very good method to solve it, okay? So we have to use a try and error. Now, but we can narrow down the range for try and error, okay? So because HJ is in the middle from the reservoir A to the reservoir B, so, and the flow is from J to B, so that the J's HJ supposed to be higher than 60 meter and lower than 100 meter, okay? So that the HJ must be in between 60 to 100 meter, okay? Must be in the range of this. For a good try, okay, you see that the middle range is 80, all right? You can try an 80 meter, okay? You put the 80 into this equation, for example. Now, 100 subtract 80 divided by 1295, and I think that should be another, okay, 2 bracket 100 subtract 80 and divided by 1295, close bracket, square root, and subtract another double bracket, 80 subtract 60 divided by 1446, close bracket, square root, and subtract by this one, 80 over 247881, okay, close bracket and square root, work out is negative 0.11 something, okay. Let's check whether the calculation has some error, okay. Note that is about negative 0.01, negative 0.011, and it's very close to 0, okay. It's already very close to 0, but is still less than this, okay. So we can try another one, okay. For example, 75 meter. 75 meter, for example. Or because I already worked it out, okay, so we try 78, okay, 78. Now, if I think that in your hand calculator you can modify the 80 with the 78, okay, but here we need to input again. Now it's 100 subtract 78 divided by 1295, close bracket, square root, and subtract 78 subtract the 60 divided by 1446, close bracket, square root, and subtract the bracket, 78 divided by 247,881, bracket, and close. It's around positive 0.010. Now, one is negative, another one is positive. That means it's already very close, okay? Now, after you have tried several times, okay, 3 or 4 times, if you take the integer, this one is already fine, okay? If you take an integer, 78 is already fine. If I take the 1 decimal places, it will be 78.1, okay? It's 78.1. This will be the closest result, okay? So that the HJ is approximately 78.1 meter by the trial and error, okay? It's not very difficult, it's not very complicated, all right? Now, so that we can solve that the Q1 is equal to, 100 subtract 78.1 over square root, okay, 1295. Right, now we can solve that out. 100 subtract the 78.1 and divided by 1295. It's around 0.130, okay? Meter cube per second. Usually we will, if there is no specially mentioned, we usually take 3 decimal places, okay? Q2 is 78.1 subtract 60 over 1446. It's about 0.112, okay? Meter cube per second. Now Q3, you actually don't need to calculate this. You just need to the Q1 subtract Q2, and it's equal to 0.018 meter cube per second. Or if you calculate, I think the result is the same. 78.1 over 247,881. Okay, now the result is also 0.018, okay, it's also the same, also pointing this result, okay, also the same as this result. So that this is a branching pipe system. You will just write the energy equation between the reservoirs and the junction, okay, following the flow direction. And then you will finally solve for the Q by using the Q to represent the head loss, okay? And then solve for the Q and put them into the continuity equation, try and error to solve the junction head, and then work out the corresponding discharge for each pipe. So this is the solution for the question 3. And next, we will go to the tutorial 4 question. Tutorial 4, we start working on the open channel thing, okay? Tutorial 4, question 1. Determine the critical depth in this trapezoidal channel for a discharge of 40 cubic meter per second. The depth of the channel bottom is B equal to 6 meter, and the side slope towards the upward at an angle of 45 degrees. Now, for the model answer, it gives us that the using the calculations of the discharge, because in the critical water flow, for the critical water flow, right? The Q square TC is the top width over the GAC is equal to 1, or the Q square over G equal to AC cubic over TC. Okay. So that if the for the Q Q equal to 40 meter cube per second. So that means the Q square over G. 40 square over 9.81 is approximately equal to 20 and equal to the AC cubic over TC. Now because the area of the trapezoidal, by knowing that the bottom width is B, the area of the trapezoidal is equal to, is supposed to be the short edge plus the long edge times the height divided by 2. It will be, now you see that because the side slope is not 45 degrees, so that if the water depth is here, and this is the this part is also the water depth, right? This is B, so that the upper TC is equal to the B plus 2y, all right? So the area is calculated by the B times B plus 2y and times the height y and divided by 2. So that B plus should be like this. So it becomes like 2B plus 2y times y over 2 and result in y times B plus y, okay, for the area. T is B plus 2y, so that in here, that the equation becomes the y B plus 2, B is 6 plus y cubic over 6 plus 2y is equal to 20. Now, also we need to try the y out, okay? We need to try out the y. Then it will be, that for try and error, okay? So you use different water depth to try it. So finally, the YC is found to be about 0.78. The model answer is 7, okay? I remember it's about 0.78. You can try later, okay? This is to answer the question. Okay, answer the question. Now I would like to elaborate more or extend more about this question. How about the normal depth? How about the normal depth? And how about if we use a fruit number to determine this? Okay. Now I will turn to another page. Now if we use a fruit number equal to the V over square root GDC to determine this, okay? To determine this, all right? Now, actually, the V it can be determined by the Q over A, all right? Square root GDC. Q, so that if the critical flow it is equal to 1, right, for this situation. But this equation is actually the same as this one, okay? So I think that is nothing very, it's nothing different, okay? It's nothing different. So this is the same actually. But we are going to calculate the normal depth, the normal depth, Yn. The normal depth is calculated by the, you can solve from the many equations. Many equation is Q equal to if using the this if using the SI unit 1 over n, A R 2 over 3, S log 1 over 2. But there seems to be need to have some more information. Okay, you still need to know the n and slope. Okay, so if we I just want to let you know how to determine the yn for this kind of shape. We assume that n for the concrete channel, okay, for concrete channel. Now for concrete channel, the now we have reference table here, okay. We'll use this table for the reference. For the concrete channel, concrete formed channel, okay, it's about 0.016 for 0.016, okay. We assume that the n is 0.016 and the slope is 0.01, for example, 0.001. Now, if we would like to determine the water depth, the normal depth, yn. Now, because we know the discharge, all right. So, but the AR for this situation we cannot, because this is not it's not a rectangular channel. We cannot assume that the RH is equal to y. So we will find that the Q is 40 meter cube per second is 1 over 0.16. The area, we know that it is equal to y times b plus 2y. Okay, y times b plus 2y plus y. R is a over p. Okay, a over p. A over p here. Then slope, this is power 2 over 3, S log 1 over 2. Then this is 1 over 0.016. This is yb plus y. Then the A is also, y times b plus y. And the P, the vector perimeter. The vector perimeter is including this. This is the vector perimeter here. Hydraulic radius calculation. So this is if this water depth is y, that the vector perimeter is supposed to be the P. The P is supposed to be the B plus 2 times y square root 2, okay, which is the y divided by the sine 45 degree, okay. So it's like B vector perimeter is like this, is B plus 2 square root 2y, okay. And times this, this is 2 over 3, S log 0.001, power 1 over 2. Now, B is known naturally, so we can write it as 6, okay? So the equation is like this. You need to try the y, okay? Also need to use a try and error. Now, so that I say, maybe sometimes in the hydraulic calculation, some of the equation you need to do try and error. But you can try, for example, 1 meters as an initial trial, okay? To save time, we can use the Excel to help, okay? If you are doing the homework. All Alright, we can try the y value, okay, y value, and we can try 1, 2, 3, 4, 5, 6, 10, okay. Now we will modify this equation, okay, maybe we subtract, just like we modify this 1 over 0.016 to compare with 0, okay? We can also combine this one. Is it necessary? But it's also fine, okay? We can combine, okay? We can y6 plus y power 5 over 3, and then b plus 2 square root 2y negative or the 3 over 2, alright, and times 0.001 1 over 2, okay. Subtract 14 equal to 0. We can maybe
我就會掉晒啲數過去。
yeah.
14乘翻嚟再同我睇。
Yeah, you have your own method, right? Now, for example, we can try doing this. Okay, so it's equal to 1 over 0.016. And multiply with the y, this y value, okay, try y value. Bracket 6 plus y power 5 over 3 and multiply 6 b is 6, okay, b plus 2 times square root of 2 times y power 3 over 2 and times 0.001. Actually, you can say the square is QRT 0.001. Contrast 14. Wow, it's quite a big number, okay? So it may be a smaller y, okay? It may be a smaller y. If we increase it, it will be very large, okay? It may be a smaller y, okay? 0.1. 0.1 becomes negative. So that we see that it's in between 0.1 and 0.2, okay? So then we can add another level, 0.11, okay? Yeah, it's 0.10 something, okay, 0.101, alright, add one more 0, alright. Now, I think that we are going to reach the true answer. So that is in between 0.101, okay. I think that is not quite, now, we can also add one more 0. That's good. Now the result is approximately 0.1. Okay, I think it's in between 0.101 and this one. Okay, for approximately it's about 1115. It's supposed to be like this. 1, 2 should be like this way. Okay, should be trying this way. So the result is around 0.14 and 15. Okay, 0.01014 is more approximately. Okay, it is 0. The yn is finally tried to be 0.1014 or approximately. Okay, it's 10.14 cm. Okay. Yeah. I think that this is because maybe. Yeah, this. I will also track the calculation. Is there any wrong in the error? Okay, maybe 14 should not be that small. Okay, slope is not large. All right, so we'll check again. Okay, so this is but the calculation manner is like this. Okay, and we're finding that the normal depth for a non-rectangular channel is like this. If it is a rectangular channel, it will be easier. Okay, it will be easier. All right. So this is question 1 of the tutorial 4, and we may stop at this moment here. Okay, and then we will talk about more next time. So for the lecture tonight, we will for the lecture and tutorial tonight, we will be up to here. Now, for the or maybe we still have some time， 或者我哋依家花好少時間去講個 assignment 咁啦。好快個多碌。嗱，咁第一題咧就係問呢度做 reservoir 呢個 flow 佢第2個啦，咁跟住個 head loss 係咁多啦 ，OK， 咁咧就會係咧就問你呢個 elevation 睇下先 ，what elevation 係幾多 ，OK， 咁呢度咧就係用 energy equation 咯嚇，咁你呢個 A 呢個 B 咁樣啦嚇，咁基本上咧ZA 同埋 ZB 嘅elevation difference 咧，就係由呢2條 pipe 去就等於佢嘅 head loss 嘅，即係等於呢2條 pipe 嘅 head loss。咁呢2條 pipe 嘅 head loss 佢因為已經呢題咧就相對嚟講唔難嘅，因為佢都講俾你聽個 discharge 幾多同埋啲diameter個 length 係幾多啦。咁所以你去呢用計翻個 V 之後咧，用翻條式咧係計到呢2個 head loss 嘅。咁跟住 B 又知道啦，咁你就可以計到 A 㗎啦。OK， 咁所以呢題就唔難嘅。咁咧後邊咧就要畫呢個 HGL 同埋 EGL 嘅。咁呢度咧就係因為佢有轉呢個嘅diameter。咁細批咧佢會係即係通常 HGL、EGL 咧會係一齊出發嘅喺個 reservoir 嘅 surface。咁佢會細批咧就會係會即係個斜度咧會大啲嘅。咁跟住咧就呢度唔考慮 head loss 佢唔考慮啲 component head loss， 咁所以我哋呢度唔使有個 drop， 咁我哋就會係第2條批咧，佢都係會冇咁斜嘅會咁嘅。energy grade line 咧就會係咪呢條實線咧 energy grade line， 咁虛線咧係咁嘅，咁去到呢度咧佢個 head 個 velocity head 咧會變細啲嘅，咁但係 係你唔淨係只畫呢個樣嘅，咁但係你都要 plot 埋呢個嘅 velocity， 即係要標埋個 velocity head 係幾多啊，同埋呢一段嘅 head loss 係幾多啊，呢一段嘅 head loss 係幾多啊，咁樣先至叫完整嘅 ，OK。第二題咧就係一個 case 2 question 嚟嘅，case 3 question 嚟嘅。咁呢啲題咧就係一個嘅一條 siphonic pipe 啊，咁我哋會咧就即係呢題咧就case 3 question， 咁你會係當呢個係 A 點，呢個係 B 點咁樣計啦 ，OK。咁佢哋嘅 energy equation 又係咧就係 ZA 減 ZB 咧就係又係等於呢個 head loss in the pipe 嘅啫 ，OK。呢條相對簡單嘅嚇，就冇乜其他嘅 component。咁咧就A 同 B 嘅 difference 咧就係細 h 加大 h。咁個 length 咧就係8 meter，OK。咁所以呢個就F 啊 L over D 啊 V 以至 over G 啊 ，OK。咁呢個 V 就即係用 Q over 去嗰個 D 去表示啦，即係 Q over A 啦，即係 pi over 4D 以至去換翻呢個 V 啦 ，OK。即係呢個要平方啦，換翻呢個啦嚇。咁你就會揾到一個 F 同埋 D 嘅 relationship 啦。咁佢參考翻我哋 tutorial 嘅幾啊 ？tutorial 3係嘛？
第2嘅第4。
tutorial 2嘅第4題咯，係啊 ，OK good，係啦，即係類似呢一題啦。咁佢呢個係咩嚟嘅？佢呢個係呢條都簡單嘅，呢條係一個嘅 smooth pipe 嚟嘅 ，plastic hose 咧係 smooth pipe 嚟㗎。咁所以你就係唔需要考慮個 relative roughness， 咁只需要係知道個assume 個 F 咧，你就計到個 D， 跟住計到佢嘅嗰個Reynolds number， 跟住就揾到個新嘅 F， 跟住 try 兩次就差唔多㗎啦嚇，咁就會揾到個diameter啦 ，OK。咁你亦都 suggest 翻佢嘅 DN 嘅數字咁樣啦，就完㗎啦呢題 ，OK。第3題咧 ，steel pipe carries water 50 mm 呢度，跟住去72 meter long， 跟住 what must be the pressure of in the pipe A to 佢個 discharge 俾到啦 ，OK。Let the entrance head loss， 但係要考慮 outlet head loss 同埋呢啲嘅 band 啊嗰啲 head loss 嘅，最直係 let entrance head loss 即係 let 呢個嘅 ，OK 呢度唔使考慮。咁即係又係呢度會係即係又係 energy equation 啦。咁呢度又係 energy equation， 其實呢題就同呢題都似嘅嚇，即係都係一條 energy equation 去 solve 翻嘅啫嚇。咁佢嘅 elevation difference 係27到6嘅，即係21 meter。咁呢度嘅管線嘅長度咧係 total 72 meter。咁呢度有 frictional head loss 啦嚇。咁佢係 steel pipe 啦嚇 ，steel pipe 咁你可以揾翻啲嘅 reference 啦。我哋主力都係睇第一個 table 啦，睇呢個 table。steel pipe 咧咁佢呢都好多嘅 commercial steel pipe wrought iron 啊，咁你可以 take 呢個0.076啦，講呢個啦，新喉啦 ，OK。commercial 呢個啦，咁0.076啦，你可以 take OK 嗱，咁當然你話，因為我哋都冇規定啦，咁你如果我睇翻你嘅 assumption 啦，咁如果你 take 其他數字，你話 take 一啲嘅 O 嘅 steel pipe 啊嗰啲 maybe wetted steel 啊都可以，你睇下你 assume 係乜嘢數，跟住去計啦。咁你可以 take 呢個0.076又或者5.6 mm 去計嘅 ，OK。嗱咁跟住你個 pipe band 啦，90度 flatted band 啦嚇，咁就係0.9啦，呢個 profile open 嘅10啦，都係同我哋個example 即係個 tutorial 差唔多啦。咁就可以計翻上游呢度 pressure 係幾多嘅 ，OK。咁呢題應該唔難嘅。 第四題咧就係、個泵嘅 power 要幾多啦 ？Find the flow distribution。嗱，呢個有個 parallel network， 跟住咧就有個泵嘅 power 啊。呢題相對嚟講複雜少少嘅 ，OK。咁由呢度到呢度嘅 energy 咧就即係呢個 energy difference 咧就係、佢嘅 delta Z 啦，就等於個泵 head 啦，係即係由個泵 head 去提供翻，應該調翻轉 ，OK， 應該調翻轉。個泵 head 咧就應該係等於個 elevation difference， 再加上佢嘅即係呢個 parallel system 嘅 head loss。咁你個 head loss 就係、佢俾咗 F、俾咗 D、俾咗 L 咧，你就用呢個嘅HL 咧，每條是但一條批就得㗎啦，其實 ，OK， 是但一條批就應該 OK 㗎啦。但係你要即係如果計嗰個泵嘅泵 head 嘅時候，同埋個 Q 嘅時候咧，睇下先。咁咧，因為個 Q 係俾咗，其實個 total 嘅 discharge 個 Q 一係俾咗嘅 ，OK。咁所以泵係計到㗎啦 ，OK。咁 head loss 咧等於呢、個佢仲要考慮埋 pipe one 嘅嗰個 loss 嘅 ，OK。咁你就要用 KQ square 嘅方式去計嗰個電 ，OK。即係等於8 FL over pi 2次 GD 5次 Q square 呢個方面去計，咁啊會好啲快啲咁樣咯。咁跟住咧去到呢度咧，你就即係其實就變咗係呢度HL 2等於 HL 3等於 HL 4，同埋呢個 Q 1等於 Q 2加 Q 3加 Q 4咧，去 solve 呢度嘅呢度分開嚟兩樣嘢㗎啦。呢、個成呢條式咧係計成個嘅不過你都要先計咗呢段先嘅，你先要計咗呢個 Q 2、Q 3、Q 4先嘅，跟住你係是但揾一條 Q 2、Q 3、Q 4其中一條批咧，去計個total 嘅 head loss 嘅。咁所以你先要 solve 呢個 flow distribution 先，跟住再通過呢條式咧去揾個泵嘅嗰個 power 係泵 head 啦，跟住再泵 power 啦。P 等於加埋 QHP 啦，即係咁樣去揾，再除翻個 efficiency 0.7。咁呢題就 refer to 我哋頭先嘅3.3啦，其實就好似㗎啦，tutorial 3.3。咁睇翻個題嘅 solution 就差唔多啦。咁呢題第6題就係、就 refer to tutorial 3.4嘅，佢亦都係即係呢度就相對嚟講同我哋嗰個係簡單啲嘅。咁呢度有一個 open loop 啦，呢個 open loop 你可以 assume 個 flow 係咁樣嘅流動啦，即係呢度會係假設我呢度係有100個 liter per second 去 out 嘅，咁你可以 assume 呢度120，係咪？呢度咁跟住咁樣流落嚟，咁跟住由20走翻去呢個reservoir， 即係一個 initial assumption 啦。咁呢度會分叉，你預可能有100呢度可能有80咁樣啦 ，OK。咁跟住呢邊咧就40走落嚟啦，跟住呢邊去咗20呢邊又上翻20去咁樣。即係你可以 assume 呢一個 initial assumption 合理地，又要符合呢個嘅嗰個 continuity equation。咁我唔知道我唔記得個具體答案㗎。呢個係隨便去 randomly 咁樣去 assume 嘅嚇。咁跟住咧你就會係計我哋嗰個 delta Q 啦嚇。咁 delta Q 去計出嚟咧就去修正翻呢啲 flow 啦嚇。咁佢呢度其他嘅大部分嘅 pipe 咧都可以用 delta Q 去修正嘅，淨係得 pipe 3咧你要修正完其他 pipe 之後咧再計翻出嚟嘅嚇，即係咁樣嚇。咁所以呢個你睇翻我哋嘅 tutorial 3.4嘅 solution 咧就 會差唔多啦嚇，就參考翻個題啦。咁頭6題咧大致上咁啦，咁後邊嗰3題咧我哋會擺去 assignment 2嘅。嗱，一般嚟講，你如果 try 6轉就差唔多㗎啦嚇，咁你就係啦，咁你一般嚟講，你 try 6個 iteration 咧，應該都基本上都數字都差唔多啦。OK。或者咁啦，我哋就講就6次 iteration 啦，6次 iteration 算啦，就唔好太唔需要太佔我哋嘅時間啦。咁嗱，咁 assignment 1咧就大致上係咁樣啦，大家仲有冇其他？禮拜一